Hello, students. So this is a activity where we're looking at visual patterns like we did back when we were learning about linear patterns. It just so happens that these are all related to our new unit, which are quadratic patterns. And what I love about this activity is you get to see the patterns in different ways, and each of the ways that you see the pattern relates back to the algebraic expression. So here on our warm up, we've got four different options, and they're all correct options for how you can see the number of tiles that are shown there on the left. And I'll just go through each of these, and I want you to try to think, how could you explain 5 plus 5 plus 8 plus 8 plus 8? One way you could show that is just by identifying, I'll use black here, that we have 5, 5, 8, 8, 8, 8. And if you add all those up, you'll get the total number of tiles. So option one is just counting how many tiles are in each row. Totally a good way to do it. Option two, let's go to option two, 4 squared plus 10. That one would be by looking at, here's a 4 square. Squared just means times itself, but it also means the number of tiles that are in there. 4 squared is 16, which is how many tiles are in that shape. And then the 10 is represented by the two fives that we talked about a little bit earlier. So it's kind of cool. You can see it in that way as well. 6 times 8 minus 2 times 3. I think this one's my favorite one. If you notice that this height is 6 tiles and then this is 8 tiles, that would give us the total number of tiles if the box was all the way filled in. But we had a little missing corner of 2 by 3. And so 6 times 8 is the whole box, 2 times 3 is the missing corner. Subtract those, you'll get the number of tiles that are there. I want you to notice also, like, I actually haven't calculated the number of tiles. I don't actually care what the total number turns out to be. What I care about more is how many different ways can I see the number of tiles. And then the last one, 5 times 6 plus 3 times 4, you can see that by breaking it down here, 3 by 4, and then here is 5 by 6, like that. And there are other ways that you could count up the number of tiles. I want you to think about if you can see any other ways of counting it up. So moving along here, we're going to look at how our pattern changes. So I see a little rectangle. Then it grows a little bit taller and a little bit wider, grows taller and wider. And so when you have something that's growing in two dimensions like that, growing both taller and wider, that's your clue that it's going to be a quadratic pattern. So here we want to build up what the next picture is. And so what I'm noticing is that the middle shape is a square, right? And then there are always two extra shapes on the side like that. That's one way that you could see it. You can see it in different ways, but that's one way that I see it. And so when I go to try to build it, what I'll do is I'll build a shape that's got a square that is 4 by 4, like this, and then see if that fills in. Good. Maybe you saw it differently, but that's one way to see it. Big square, two little tails on the bottom. How many tiles will there be when s equals 10? Well, I'm going to have a big square that's going to be 10 by 10, and I'll have two little guys on the side. So altogether, that makes 10 by 10, so 100 plus 2 tiles, 102. Let's see. 102 tiles, look at them filling it in right there. Pretty nice. Just going to do a couple more slides here and let you work on the rest of it. One thing I want you to notice is that, like we've done a couple times, when you're looking at a pattern, a quadratic pattern, you should be able to see that your rate of change itself has a nice pattern to it. See how all I'm doing is calculating how much I need to add to get from one y value to the next y value. And you should notice that the pattern here in my change is itself a linear pattern. right there. Okay. Now, that doesn't mean that the pattern relating S in the number of tiles is linear. It just means the rate of change is linear. What kind of relationship is there? It's called a quadratic one. It's not linear because it's not going plus the same number every time, and it's not exponential because it's not going times the same number every time. Here we can see a new pattern that's also growing in its length times width. So it also seems to me to be something that's growing quadratically. And I'll stop with this slide here. Uh, and I'll ask you to keep working on it and comment or question if you need anything. But you can see here two different ways, Abdullah and then Deja. Abdullah says a square plus 2 rows. So here's your square maybe on the bottom, and then 2 rows like this. You can see a square and 2 rows, square and 2 rows like that. Or Deja, I'll use a blue for Deja, is I see a rectangle where the length is 2 more than the width. So here we have a 1 plus 2 versus a 1. Here we have 2 plus 2 and 2. Here we have 3 on the bottom and 3 plus 2 on the side. Both students are correct. Abdullah sees it as a square plus 2 rows. Deja sees it as a rectangle where the length is 2 more than the width. In either situation, you can get that the total number of tiles, the y value, is equal to the s multiplied by s plus 2. That's how Deja sees it. Or how Abdullah sees it is a square plus 2 rows. And the last thing I want to do in this video is just have you look at these two expressions and think about what thing we've used many, many times this year that could turn the blue expression into the purple expression. And this is the most beautiful part of math, is when you visualize something and you can see it in multiple ways, and then you step back into the algebra and you can see how the algebraic connections are the same logic as the visual connections. So please comment, ask questions if you need anything else, and enjoy the activity.